All right. We are still working on factoring. So, hope that you got your homework out. Let's go to work. I want to start with reviewing what we've been talking about and then get into the box method more specifically today. I gave you a video on box method, but we all know video is not as good as live and in person. So, let's go. Just as a couple quick reminders, factoring is we're taking a quadratic from standard form and manipulating it until we get to intercept form, also known as, anybody? Good morning. I know it's Monday. Let's wake up. Everybody stand up. Come on, stand up. Come on. Shake it out, stretch. Let's go. We got a lot to do today, this week, so I ain't got no time for sleepyheads. Everybody up? Good? We need to do some push-ups. What? Let's go. What is another name for intercept form? Factored form. What is another name for intercept form? Factored form. We are factoring quadratics. Why? Why would we factor quadratics into intercept form? So we can see the roots, the zeros, the solutions, the x-intercepts quickly and easily, okay? In the last week, we learned the process for how to factor, okay? And here it is, right here on the screen in front of you. The process, we're going to ask ourselves some questions, and our answers to those questions dictate what we do. First and foremost, we always ask for a GCF. What is GCF?
Greatest common factor.
Yes, we're awake. Greatest common factor. Okay, we're looking to see if there's something that goes into every part of the quadratic. If we do and we can pull that out, it's going to make our life easier. If you don't, you can still factor it. It's a lot harder to do. So we always want to take out the GCF first. Next question is there a leading coefficient? And this is where we're going to diverge one of two different directions. If there's no leading coefficient, this is what we spent the first part of the unit working on, was splitting signs. Just as a quick refresher, let's make one up here. Let's go x squared plus 7x plus 12. Okay, and we'll set that equal to 0, right? Yes, we like it equal to 0 because that's what we're looking for, zeros. Okay, so if I ask my question, is there a GCF? Everybody would say,
No.
Is there a leading coefficient? So, splitting signs. That means I'm going to put two sets of parentheses. That's the split with an x in each. And then my signs mean I look at my last sign, and that tells me whether they are the same or opposite. In this case, it would be the same. And when they're the same, I look at the one in front of it to see whether they're both positive or negative. In this case, they're both positive. Now, after I split in signs, then I list the factors of my constant. In this case, my constant is 12. The factors are 12. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. And that's it, right? Which of those come together to get me a 7? 3 and 4. And I put them in right there. It doesn't matter in this case which one goes where. So what are my solutions then? They are -3 and -4. Remember, opposite of what's there, yes? Matter of fact, if I were to graph this, 1, 2, 3, 4, it would cross. It would look something like that. Hey, this graphic is going to come back to you real quick here in about a week. And you can be like, oh my goodness, why didn't you show me that earlier? And I'd be like, because you wouldn't have learned anything else if I had. Yeah. All right. So that was splitting signs. And I think everybody's doing well with that. Yes? A lot of head nodding in here, okay? Now, what if our answer to is there a leading coefficient was yes? Yes, there's a leading coefficient. Well, when that's our answer, let's go through the process, okay? Now, I'm going to jump to your homework here and use these problems, okay? So, again, first question, GCF. Is there a GCF here?
No.
No. I know it's not for several reasons. One, all three of those numbers are prime. What's prime mean? They only got two factors, one in itself. So I know there's no common factors there because one doesn't count as a common factor because one goes into everything. Okay. All right. So is there GCF? No. Is there a leading coefficient? Yes. So the next thing that comes out of your mouth is box method. Box method. Okay. That's cool, but what does that actually mean? Well, it means exactly what it sounds like. We are going to draw a box and put a window in it. Get it? See the window? Okay. Now, once you drew the box, you're going to take your first term and put it in the upper left box. And you're going to take your last term and put it in your lower right box. Everybody think they can handle that? Do that, please. 2v squared and 5. Okay. Now, I take those two numbers. I don't worry about the variable, just the numbers, and I multiply them. In this case, it would be 2 times 5 gets me 10. And I write it up there kind of where I did always to the upper right-hand corner. I put the list of all the factors of the constant, right? When I multiply those two numbers together, I'm going to write that up there because guess what? I'm going to list all the factors of that number. In this case, it's 10. So what are all the factors of 10? 1 and 10, 2 and 5. That's it, right? Which of those come together to get me an 11? 1 and 10. Now, I take those two numbers. Now, I also know that the signs of those two numbers are the same and both positive. See how that's similar to what we were already doing? Okay. So I'm going to take those two numbers and I'm going to put them in the other two boxes. 1V, and I'm going to put a variable with it, and 10V. Now, does it matter which one goes where? Nope. Doesn't matter. You can't mess it up. Just put one in one box, the other in the other box. Honestly, that's the hardest part. Because now, all I'm looking for is the GCFs, the greatest common factors. Okay, so now I look this direction. I look at these two right there. 2v squared and 1v. What is the greatest common factor there? Well, there's no number between 1 and 2. Oops. Uh-oh. There's no number, but I can pull out the v, right? How about here? Between 10v and 5. What is the greatest common factor? 5. Now I do the same thing going up and down. Looking at the first one. 2v squared and 10v. I can get a v, but I could also get out a 2, right? And then finally, looking at this last one, up and down. A 1v and a 5. Just a 1. And then that is my factored form. So I have 2v plus 1. Why is it plus 1? Well, because that's a positive 1. And then v plus 5. And that is how you factor using the box method. Okay? It's, again, a process. If you follow the process step by step, it's not that bad. Can I get a whoop whoop? Let's try number 6. Try number 6. All right. Go back to blue. Is there a GCF? No. Is there a leading coefficient? Yes. So what am I going to use? Box method. Now let's kind of break down this box method. Okay? What's the first thing I do in the box method? The first and last in the box, right? I put the first term and the last term in the box. Where does the 2n squared go? Top left. 2n squared. Where does the 2 go? Bottom right. Okay, so I put the first and last in the box. Then what? Now what do I do? Yes, I multiply those two. So in this case, 2 times 2 is 4. And after I multiplied, I list the factors. So list the factors of 4. 1 and 4, 2 and 2. Which of those come together to get me a 5? 1 and 4. Signs are the same, both positive. So 1n and a 4n. And then finally, a GCF again. GCF. What is the greatest common factor? Just an n, right? What is the greatest common factor? 2. What is the greatest common factor? One more time. My finger's too fat. Wow. Let's try this. Still too big. There it was. So what can I pull out? 2n. And the last one. Just a 1. Yeah. So I've got 2n plus 1 times n plus 2. How are we doing on the box method? Okay? Better? Let's try this one on our own. I'll give you 30 seconds. Go. All right. Is there a GCF? I look right away and I saw the 7 and the 28. 7 does go into 28, but doesn't go into 53, does it? 7 times 7 is 49. Next one would be 56, so it doesn't go into 53 evenly. So is there a GCF? No. Is there a leading coefficient? Box method. 7a squared and 28. Uh-oh, we're getting the big numbers here now. 7 times 28. 7 times 28. 7 times 8 is 56. 2 times 7 is 14 plus 5, 196. So I got 196. Factors of 196. 1 and 196. 2 and 90 what? 98, right? 2 and 98? Yes. 3. Does 3 go into 196? How would I know? Come on, I showed you this last week. How would I know? Yeah, if I add up the numbers 1, 9, and 6, 1 plus 9 plus 6 is 16. Is 16 divisible by 3? No, so 3 doesn't go into it. Okay, next one, 4. Does 4 go into it? Well, 4, you can just look at the last two numbers. 96. Does 4 go into 96? Yes, it does. So it goes into 196. 4 goes in. Well, 4 goes into 19 4 times. And then that would be what? 36, 49. Does 5 go in? How would I know if 5 goes in? It ended in a 0 or a 5. Okay. Does 6 go in? I don't know. How do you know if 6 goes in? Well, if 2 and 3 go into it, 6 goes into it. Does 2 and 3 go into it? No, 3 doesn't, so 6 doesn't. These are your divisibility tests. Okay, does 7 go into 196? 7, 14, 56, yeah. 7 goes into 19 twice, right? 19 minus 14 is 5, 5, 6, 56. Goes in 7 times 8 is 56, right? Does 8 go into 196? 8 goes in, does not, right? 8 goes into 19 twice, 3 left over, that'd be 36, but doesn't go into 36, so no. Does 9? No. 10? No. 11? Do I really have to keep going? No, why not? So I already got my 4 and 49, which is my 53 that I'm looking for, yes? So stop there. So 4A and 49A. Everybody understand how I got those two numbers? Okay, now I'm looking for my GCFs. A, 7, 7A, 4. So 7A plus 4 times A plus 7. One more time. How do I check? How could I check to make sure that I'm right? Yeah, FOIL it out. So let's FOIL this one out just for fun. 7A times A, 7A squared. 7A times 7 is 49A. 4 times A is 4A. 4 times 7 is 28. Combine my like terms in the middle. 7A squared plus 53A plus 28, which was what I started with in the first place. Can I get a woo woo? Are we having fun? Yes. All right. I'm going to stop there before I transition to something totally different. Those you watching, have a great day.